Hi, grade 8. This is the math video for chapter test 4. It's actually a practice test for chapter 4, form 2C. The first two problems are deciding whether or not certain numbers are divisible by 2, 3, 5, 6, and 10. Well, you have those divisibility rules. Remember, a number is divisible by 2 if it ends in an even number, like 0, 2, 4, 6, 8. A number is divisible by 3 if you can add up the digits and the sum is divisible by 3, then the whole number is divisible by 3. A number is divisible by 5 if it ends in 0 or 5. A number is divisible by 6 if it's also divisible by 2 and 3. And finally, a number is divisible by 10 if it ends in a 0. So the first problem, number 1, is the number 1,000. Is it divisible by 2? Yes. It ends in an even number, so it is divisible by 2. Is it divisible by 3? Well, when I add up all the digits, 1 plus 0 plus 0 plus 0, that's the number 1. That's not divisible by 3, so therefore the number's not divisible by 3. Is it divisible by 5? Yes. It ends in 0. Numbers that end in 0 are divisible by 5. Is it divisible by 6? Nope. If it's going to be divisible by 6, it also has to be divisible by 2 and 3, and we don't have that going on. Is it divisible by 10? Yes, because it ends in 0. So there's the answer for that one. Number 3 through 6, nope, numbers 3 and 4 rather. The directions say determine whether each expression is a monomial. Numbers 3 and 4. Well, do you remember how we talked about that? What determines if something's a monomial or not? I said be on the lookout for a subtraction sign or an addition sign. If I write something like this, 7 times 6 times s times t times u, that is a monomial. That is, because there's no subtraction or addition sign. If I put a negative symbol out in front, it's still a monomial because there's no subtraction or addition signs. But if I were to take this and go like this and write STU added to 7 times 6 or negative 7 times 6, that's not a monomial. How about number 5? That should be pretty easy. They're asking you to write 2 to a certain power, right? Number 6, just take the number 2, put it where a is, and solve whatever 7 times a to the third power is. So it would be 7 times 2, and the 2 is to the third power. Now, the big question is, do you do the exponent first or do you do the multiplying first? Be careful. How about 7 and 8? You're writing prime factorization. If I had a number like 84, what would the prime factorization of that be? Well, I'm going to write a whole bunch of factor tree situations on the board until I get down to just the prime numbers that are left over. If the answer was 84, it would be 2 times 2 times 3 times 7. How about something like number 8, where it's 42 times a to the third power times x? Well, I'm not going to do that one, but what if it looked like this? Well, I would break down the 36 into its prime factored form, and that would be 2 times 2 times 3 times 3 using a factor tree, and then I would write times b times b times c. Factor the number, and then factor the variables. Do you remember how to find the greatest common factor of 3 numbers? What if I had 24, 30, and 48? And I said, find the greatest common factor of those 3 numbers. Well, first, I could either do a factor tree situation, or I could do a situation where I'm listing all the factors. And that's what I'm choosing to do this time. I'm listing all of the factors that multiply together to make these numbers. And then I figure out what they have in common. Nope, they don't have 6's in common. Uh-oh. Looks like in this case, the biggest factor they have in common is 3. 3 is the greatest common factor. That's the biggest factor they have in common. Or I could do the factor tree thing as well. Let's see how we do that. If I factor 24, that's really 3 times 2 times 2 times 2. But I'm going to put the 3 on the other side, doing a factor tree. The number 30, that would be, what, 2 times 5 times 3. And the number 48, what would that be? Well, 48 is what, 6 times 8. So that would be 2 times 2 times 2 times 2 times 3. What do they have in common? They have a set of 2's in common. Do they have anything else in common? They have a set of 3's in common. What's 2 times 3? 6. Guess what? I made a mistake. I made a mistake over here. I missed a set of factors, didn't I? Where did I miss it? I missed it right here. 5 times 6 is 30. So 6 is a common factor of all of these. My mistake. Sorry. Greatest common factor is 6 in this particular case. What about something like 20y and 30y squared? Well, I would factor this first, and then I would factor this second, using a factor tree. And then I'd look for what they have in common. They have a set of 2's in common, a set of y's in common. So the greatest common factor is 2 times y. Greatest common factor is 2 times y. How about factoring a binomial? Do you remember how to do that? If I had 16 times x plus 4, think of the biggest number you can factor out of both of these, or divide out of both of these. That would be 4, and so in this case I get 4x plus 1, because 16x divided by 4 is 4x, and 4 divided by 4 is the 1. I'm going to do something similar to number 14. If I said 20 minutes is what part of an hour? What would you say about that? I would say create a fraction and simplify it until you're down to simplest form. 20 minutes is what part of an hour? Well, an hour is 60 minutes, so 20/60ths simplifies down to 1/3. I'm going to stop at this point. If you have other questions, please ask. Thank you.